Hey guys, today we're going to be presenting a supercapacitor torch. My name is Sean van Rensburg.
I'm Dean Golden.
And I'm Marcochip.
So basically our torch powers two 100 milliwatt LEDs and it has functionality in which the user can control half brightness and full brightness. And on the board here is our circuit or block diagram that briefly explains the circuit, but the whole thing will be explained in detail shortly. Alright, so we've set up our supercapacitor to charge through the bench supply at about 6 amps, and it's going straight into a comparator circuit which is set to indicate when it's fully charged at about 2.45 volts. And this should show you here that as soon as it reaches 2.45 on the multimeter or just above, this LED should indicate that the cap is fully charged. And then you know to switch off the bench supply as soon as it's ready. See there. So 2.5 volts, the LED switched on, and we have to switch the bench supply off ourselves. Alright, so now that it shows that our supercap is fully charged to about 2.5 volts, we can switch the torch on, and then the charge indicator goes off. And to show that it's completely running on the supercap on its own, and take out the battery for the reference, and then the whole circuit's now running from the supercapacitor.
Okay, so now we're going to speak about the PWM implementation for our circuit. Basically, it acts as a switch for the MOSFET, which will allow the booster circuit to maintain a 5-volt output. We've implemented a feedback system which takes a signal from the booster circuit, reads it into our PWM circuit, and the duty cycle is altered based on that to maintain the 5-volt output of the circuit. Initially, we wanted to power up Atmega 328P from the bootstrap circuit, but unfortunately, we couldn't keep the bootstrap on, the Atmega on for long enough to get the PWM on for long enough to keep the output at 5 volts. So we've investigated a cheaper and more efficient option, the AT-Tiny85 microcontroller, which has an on voltage of 1.8 volts, which is enough to be turned on from the initial output voltage of the booster circuit.
Alright, so we're going to now discuss the boost converter component of the circuit, which in effect takes the low voltage from the capacitor, boosts it up, as the name says, to around 5 volts so that the LEDs can turn on, which have a turn on voltage of 3.5 volts. To give you a basic understanding of it, we have an inductor, a MOSFET, a capacitor, and our two LEDs with a switch to turn one LED on as our half brightness, as is indicated below. The inductor, the MOSFET, and the cap make up a basic design along with a Schottky diode over there. The MOSFET has a turn on of 2 volts, the inductor is 110 microhenry, and the cap is 120 microfarad. Them together boost the voltage from 2.7 to 5 volts. In the video, we've shown how to successfully implement a supercapacitor torch. Thank you all for watching.